Welcome back to the Deep Dive, where we take complex documentation and, well, give you the knowledge shortcut. Today, we are digging into the biggest and, honestly, often ignored enemy of high-density professional AV equipment: heat.
It truly is. It's the silent killer of uptime. If you're running serious rack gear, say video processors or modular switchers, you just have to manage your thermals.
Right.
Performance can't waver. And, system reliability, it demands very specific infrastructure just to maintain the lifespan of the components.
That actually brings up a question for me right away.
Mm-hmm.
If the equipment stack is like a high-performance racing engine,
Good analogy.
then why does the radiator, in this case, we're looking at the tvONE 1RK-5RU-FAN for ONErack systems,
Yeah.
why does it have to be so tightly engineered?
Because that radiator, it's not an option. It's absolutely critical infrastructure. We're talking about environments where a single failure can mean lost revenue or, a mission failure.
Okay, let's unpack this component then. The 1RK-5RU-FAN. It rings up at $285. So what kind of engineering are we talking about here that gets you to that price tag?
Well, it's defined by performance metrics you just won't find in consumer gear. First, it uses these large, what they call super quiet fans.
Okay, quiet is good.
And second, and this is the big one, it delivers a huge amount of cooling capacity. We're talking up to 225 CFM.
225 CFM. That sounds like a big number, but can you give us some context? What does that kind of airflow really mean inside an enclosure?
It means you have serious, dedicated airflow for just a few pieces of gear. To put it in perspective, 225 CFM is roughly enough to completely ventilate a small bathroom every single minute.
Wow.
So it's a very targeted, high-power airflow designed to get immense amounts of heat out, and fast.
So that's the brute force. But I imagine the real engineering challenge isn't just the force, it's the finesse, right? Tell me about the customizability, like the user configurable push or pull airflow.
That control is absolutely essential. It goes beyond just simple cooling. This is about environmental protection. Installers can fine-tune the solution for either positive or negative pressure.
And why would an installer choose one over the other? What's the thinking there?
So positive pressure, where the fan is pushing air in, it forces air out of every little seam and opening. This is critical because it keeps dust, smoke, other contaminants out of your sensitive electronics. It's an active defense strategy.
And that precision also ties into the user-controllable fan speed, I'm guessing. So you can balance cooling with noise.
Exactly. It's that constant trade-off in a professional install. You need the cooling, but if the rack is near human operators, say, in a broadcast booth, the noise level can't be unacceptable. You need that flexibility.
Given how critical this is, I imagine you can't just run this off a standard power strip.
Oh, no.
This has to tie into the main on-rack power architecture, doesn't it?
It does, fundamentally. The fan cover has to be powered by specific PSUs, like the standard 1RK-5RU PSU or the more high-end redundant one.
Wait, hold on. So you're saying this $285 accessory has to plug into a power supply like the, what is it, the 1RK-5RU PSU2 HSWP?
The dual redundant one, yeah.
Yeah.
Which is priced at $1,750.
Oh, yeah.
That tells you everything right there about the budget for professional reliability.
That's the key insight, really. The cost of that redundancy is the cost of mitigating risk. It's an insurance policy.
So the fan is really just the seatbelt for all the high-end hardware inside.
A very important seatbelt. And you see this across the whole ecosystem. For instance, the system is TAA compliant.
Meaning it meets U.S. government procurement standards.
Exactly.
Yeah.
Which tells you it's built for clients where uptime is completely non-negotiable, whether they get it from HDTV supply or somewhere else.
So the takeaway here isn't that the $285 fan is expensive. It's that the another $750 redundant power supply shows you where the real cost is. It's the absolute guarantee of uptime.
It is. Maximizing performance demands that kind of careful, deliberate management of heat, power, and all the accessories.
Which brings us to our final thought. Right. This focus on things like CFM and power redundancy, it really raises an important question for you to think about. How much of this hidden infrastructure is critical to every piece of high-performance tech that you rely on every day? What's the radiator in your own infrastructure that you never see but you completely depend on?